All right, well, welcome to NANOG. My name is Brent Chapman. I'm with Automata. Just real briefly, let me introduce myself and then talk about what I'm here to talk about, and then we'll slam through things. I will say right up front, I have 180 minutes and 150 slides. So I don't think I'm going to get through them all, but I am going to go through this talk rather faster than I would for a typical audience, because I don't think this is a typical audience. I think this is a group of pretty sharp people that are going to understand what I'm saying pretty clearly and quickly. However, feel free, please interrupt me with questions as we go. I may ask that we defer certain questions till later, but please do interrupt me as we go. You may have to jump up and down and wave to get my attention because the lights in the back are kind of blinding. But I do prefer to take questions as we go. All right, so who am I? As I said, my name's Brent Chapman. I am a consultant, network architect, sysadmin, author. I wrote the O'Reilly Firewalls book. Developer. I wrote Majordomo. I wrote the Automata Config Generator, which is my new open source tool that we'll talk about a little bit later. I used to be in the height of the .com boom. I was Covad's director of network architecture. I built and ran the network engineering team at Tellme. So, you know, I've done a little bit of stuff like this. What I'm here to talk about is why you should automate the configuration and management of your networks and how you can do it. If you're already sold on the concept, today's talk hopefully will give you some ammunition that you can use to sell other people on the concept. If you're not sure about why you should or shouldn't, hopefully by the end of this talk you'll be convinced. And you know, hopefully everybody will pick up some of the tools that are available here. So why, in a nutshell, do you want to automate the configuration of your network? Basically because automated networks are more reliable, easier to maintain, and easier to scale. Okay? We're going to go through each of these points in more detail, but those are the big three top-level items. So for example, imagine that you're running a moderately complex web service, web-based service. You know, you're hosting salon.com or something like that. You're running multiple hundreds, possibly thousands of real and virtual hosts. You're running several separate environments, production, development, testing, staging, so on and so forth. Maybe you've set up a separate VLAN for each of those environments. Think about what devices and services need to be managed for each of those environments. You've got the routers, the switches, the load balancers, the firewalls, the real-time monitoring system like Nagios, the trend monitoring system like MRTG. Okay, so now think about what you have to do to add a new virtual host to one of those environments. Think about all the steps you have to go through. Beyond setting up the host itself, which is a whole separate can of worms, although the people that deal with hosts these days using tools like Puppet, Chef, and CF Engine and so forth, they've got a pretty good handle on automating the installation and configuration of hosts these days. It's the networking side, it's us that are, you know, way behind. But just on the networking side, once you've got the host itself set up, you've got to set up the VLANs on the switches. You've got to set up ACLs or modify existing ACLs. You've got to add the host to the load balancer. You've got to modify the firewalls. You've got to add it to the real-time monitoring system. You've got to add it to the trend monitoring system. What's the problem with doing all of that by hand? Basically, first off, you have to remember how to do it all by hand, or you have to take the time to refer to the notes that somebody else or yourself earlier has taken the time to write. Okay? A lot of different devices involved in this, especially if you're a sysadmin or you tend to specialize in one type of device or another. You may not be that familiar with the other devices. You know, contrary to popular belief, not everything runs an iOS CLI, even though some of them look like it. There's some fine-grained differences. It takes a lot of time to go through and do this stuff by hand. Everything that you do by hand is a chance that you might make a mistake, a typo, or skip a step. You might get distracted in the middle of it by some other crisis and never finish. You know, stuff. Somehow we never get around to adding stuff to the monitoring systems until it fails and we didn't notice. Okay? How many have had that happen? Okay? Yeah. Over time, all of these small mistakes add up. Right? And what you're left with is an inconsistent network that's less reliable than it should be, harder to troubleshoot than it should be. Okay? Here's a little bit of math. If you've got 6 steps in a process, and you've got a 95% chance of completing each of those steps correctly, without typos, without getting interrupted, whatever, all right, when you chain 6 of those steps together, you only have a 75% chance of getting through the whole process correctly. 0.95 to the 6th power, okay? So the more complex your network gets, the more complex, the more number of systems you have to touch to make some change, the higher the odds are that it's going to be wrong somehow or incomplete somehow when you think you're done. Okay, so now in a little more detail. And again, hopefully this stuff is obvious to everybody, and hopefully you can use these arguments to convince other people back at your workplaces why you folks ought to be doing these things. But why do I say that automated networks are more reliable? Well, unlike typical hosts, network device and service configurations are heavily cross-dependent across devices. Right? Your typical host config, whether it's a web server or whatever, there's very limited stuff that you need to configure outside of that particular host. It needs to know, or maybe it learns via DHCP, who its DNS servers are. It needs to know what its own IP address is. It needs to know a couple of other things. But it's actually fairly self-contained. Now, if you consider your typical network device, your typical router, switch, load balancer, firewall, it's got its fingers in everything. All right? It's got to know what's where and who does what, and it's complex. Okay? So what you do over here affects what happens over there and whether or not it works. Think about IP address assignments and things like that. And this stuff has to be consistent across the board throughout your whole network in order for everything to be as reliable and as easy to troubleshoot as it should be. Network devices and services today are typically hand configured. Most of us are still managing our network devices by hand. We have fallen into the fallacy of saying, well, we've got thousands of hosts but only 2 routers. So, we'll just do the 2 routers by hand. And we'll automate the thousands of hosts. Never mind that either of those 2 routers is much more critical to your operation than any one of those 1,000 hosts. Okay? If you think of automation purely in terms of numbers, of doing more, you're missing the real benefits of automation, which are consistency and therefore reliability, maintainability, scalability. Okay? So, second problem with doing everything by hand is people make mistakes. People are very creative, but very bad at doing things reliably and repeatedly. Okay? People make typos. Okay? Also, people, when they're hand configuring devices, a big problem that I see a lot is not missing config files, but extra config stuff that shouldn't be there anymore, that isn't relevant anymore, that should have been removed. And every time you go to debug one of these configs, you have to wonder, why is that line there? Is it important? Do I dare delete it? And you spend time thinking about it. So these inconsistencies cause problems. What kind of problems do they cause, these manually induced inconsistencies? Well, first there's the obvious direct costs. Okay? Outages, intermittent failures. I love intermittent failures. I'm a consultant, right? I can charge by the hour for those. They're great. Okay? Service degradation, things just aren't performing the way they should. They're sort of limping along, but not really getting there. Time spent troubleshooting. Hey, I charge by the hour for that. It's great. I love it. But there's also the indirect costs of unreliability, and I think these are actually even more important. Right? The biggest indirect cost is it reduces the utility, the usefulness of your network to your organization or your customer or your user base or whoever it is that your network is important to. People don't trust the network because it's unreliable, okay? And they tend to treat it as fragile. And so they tend to delay releases, or they tend to delay new features, or all sorts of follow-on effects from having what is perceived to be a fragile network, okay? People become, the IT staff, the networking staff becomes reluctant to make changes to the network because they think it's fragile too. They're not sure if I change this over here, what's going to happen over there, okay? because the network has grown so complex because of these manually introduced inconsistencies. And so, and also, your staff, your networking staff, spends a lot more time troubleshooting the network, trying to figure out, does this inconsistency between these two devices matter? Is it the source of this problem that I'm seeing? And less time being proactive, introducing new features, new services, so on and so forth. Okay? All right. So that's more reliable. Why do I say that automated networks are easier to maintain? Well, and again, we're going to hit each of these points in more detail. So we'll start with, they're easier to troubleshoot. Okay? An automated network, because the configs are more consistent across the board, they're easier to troubleshoot because you don't, when you see a line that's there, you don't wonder, hey, is that left from that site that we got rid of 6 years ago, and maybe we should delete that, but no, the configs tend to be, with an automated system, more compact, more correct, less inconsistent, just more reliable. With an automated system, with an automated network configuration, it's easier to test your changes because you can make your changes in a lab or a single field office or something like that, some limited setting. Test them, and then when you are comfortable that those changes are correct, roll them out across 10% of your network. And then when you're comfortable it works across 10% of your network, roll it out across 100% of your network. But with an automated tool, it's much easier to say, how can I reproduce these changes into production? Okay. It's easier to deploy changes network-wide. Right? There are some changes that we ought to make that it's like, oh man, if I do that, I'm going to have to go change every single device. And therefore, I'm not going to make that change. I'm not going to change my DNS settings. I'm not going to change my DHCP settings. I'm not going to change my SNMP community string. I'm not going to change, whatever it is. It's just too much work. I'm not going to do it. Because, I don't want to have to go touch all those devices by hand. Okay? Because I know I'll miss some of them, and then I'm worse off than I was before. All right? With an automated system, it's easier to make those sorts of changes. It's faster to make changes. Automated tools can very quickly generate new configs for your devices and then deploy those configs to the devices. Now, obviously, this is a two-edged sword. Okay? This is juggling chainsaws. You can blow your foot off, or cut your foot off, I should say, stick to the metaphor. So, on the other hand, it also makes it easier to back things out. If you decide, yes, I've deployed it widely, and nope, I shouldn't have done that. As long as you preserve out-of-band console access or whatever mechanisms you have for getting back into those devices, yeah, if something blows up big time, you can back it out quickly too with the same sort of automated tools. Okay. Well, here we go. It's easier to roll back changes if you need to. Okay. Automated configs, your automated configs can be stored under version control, so you know what changed, when, why, who, so on and so forth. And the automation tools can roll the changes out quickly and roll them back quickly if needed. All right, now, the third point, right? More reliable, easier to maintain. Third point is easier to scale, okay? Automated networks are easier to scale in two ways. First, it's easy to add more systems of existing types, which, horizontal scaling. It's easy to add one more site. It's easy to add one more load balancer. It's easy to add one more environment that's a parallel to your existing ones, right? You've got the tools, you've got the templates, you simply feed the new parameters in, and boom, you've got a complete set of configs for that new site, that new device, that new environment, whatever, okay? And it updates all of the dependencies as well, right? So, when you add a new environment or a new site, it updates your monitoring system, okay? And then it's easy to deploy those configs to that new site, again, using the automated tools. Less obvious, though, is that an automation system also makes it easier to do vertical scalability, to introduce new features, new types of systems, new services, okay? It's easier to add one more type to an existing automation system than to do it all by hand. Okay. All right, any questions as we go? Is this all blindingly obvious? Okay. Levels of automation. Let's talk about the various levels that you might go through as you go down the yellow brick road to automated nirvana. Okay. You're going to start with no automation, probably. Almost everybody starts here, and a lot of people are still here. Okay. This is probably typical of most of today's enterprise networks. Hopefully it's not so typical of the networks in this room, this audience, but this is true of most networks in general today, in my experience. Configs are edited manually, in place, live, on the production boxes. You know, I mean, how many of us have typed the command and sat there waiting? It's like, do we dare hit return? And you hit return, it's like, does the prompt come back? And the prompt come back. And you wait a few seconds and you hit return again to see if it's still there. Yeah, happens. That's the way we do it. So configs are backed up by hand, haphazardly, if at all. Yeah, I think I have, you know, a copy of the config file for that router from 6 months ago when we added the new fields. Well, what other changes have we made in the last 6 months? I don't know. This, you know, this basically depends on people to follow procedures reliably and consistently, and people are just bad at that. That's not what people excel at. That's what computers excel at. So let's use computers to do it. Okay. So the next step that a lot of people get to is what I call read-only automation, which is basically automated backups. Okay. Rancid is a great tool for doing this. It'll basically go out and pull down your router configs and device configs from whatever devices you pointed at and save them away in a directory and tell you if they change. You know, if somebody makes a change on the device itself since the last time Rancid was run, it'll tell you and it'll send you a diff. Okay, great. You're still managing your configs by hand, but at least now you know when things have changed and you have some repository of the most recent state of things so that if a device rolls over and dies, you can put its most recent config on its replacement. So that's, you know, one of the downsides here is these systems generally, they only check the systems you tell them about. So if you add a new site, hey, this is one more thing you have to remember to do as part of adding a new site or adding a new router or adding a new whatever. You got to go remember to add it to the backup system. Okay. So the next step beyond that is automated discovery. So you're still managing your configs by hand. You're using Rancid or something like that to back up the configs. But you also layer on a tool like NetDisco or OpenNMS or something like that to discover new network devices, new routers, switches, load balancers, firewalls, things that you ought to be able to back up and manage. And you do that. Interestingly enough, this is basically the way the IETF meetings operate, the networks for the IETF meetings operate. You know, and if you're curious about that, Jim Martin is sitting here and he'll be here all week and can tell you all about it. But it works, right? Because you've got to deploy, you know, a 60 router, 100 access point, 10 VLAN network in 2 days in a strange city that you all just flew into and are horribly jet lagged from, right? And it's got to be up and running for the conference for a week, and then you got to tear it all down again. Okay. Well, the way they do that is they have a set of equipment and they run basically the same configs each time, each meeting, and they plug in what they need, and the management system figures out, okay, this week we have 14 switches and 67 access points, and here's what they are, and I'm going to go monitor them. It works. So the next step beyond that is automated configuration deployment. So you're still maintaining configs by hand, but no longer on the active devices. You're maintaining the configs centrally, hopefully making changes consistently across configs, and then using tools to push those configs out to the devices in question from that central location. So you can use Rancid to do this in what's called push mode, or you can use custom expect scripts, or you know, if your devices support it, you can use rsync or SCP or whatever. This is one of the places where it really helps to have a out-of-band centralized console access to everything via something like conserver. Okay. But you know, that's the next step down the path. Then the step beyond that is where I've been working for the last couple of years, and that's where you start doing automated generation of those configuration files. All right, so you start treating your config files as compiled code, if you will, and you generate them so that they are consistent across all of your devices, across all of your services every time. Okay? You're still deploying them by hand, you're still backing them up with Rancid or something like that, but at least they are being generated consistently so that, you know, the IP address of the syslog server is in every device and it's not typoed on 3% of them. The IP address of the name server, the SNMP community string, all of that stuff, you know, is consistent across all of these devices. And if you want to change it, you need to change it in one place and regenerate all of those configs and then push those configs out. Okay? The next step beyond that, which some organizations have gotten to, especially some of the larger carriers and so forth, is automation of both generation and deployment. Now, sorry, I don't mean to imply that they're using NCG, that these large carriers are using NCG to generate the configs. To my knowledge, none of them are. But the large carriers have developed their own similar tools. One of the reasons I wrote NCG is because I knew all the large carriers had these things. We had built things like this at Covad. We had built things like this at Tellme and so forth. And I was getting tired of rebuilding the same damn tool every time I went to a new carrier. And so I decided to do something and make it open source and hopefully build a community around it. And that's the idea behind NCG, and we'll talk a little more about NCG later. But you know, you're generating config, you're using Rancid in push mode or something like that to push them out. Another step would be automated auditing of the running configs. So in this case, you've gotten your network to the point where you think that what should be running on all of the devices in production are the configs I generated. And if that's not true, I want to know about it. If somebody has made a change manually to any of those devices, or if a new device has appeared or whatever, I want to know about it. All right? So you audit against your generated configs. And then the final step that I think people would get to would be some sort of approval process wrapped around this whole thing, where basically you develop and test your configs in a lab setting, and then request and receive some sort of approval before deployment, some sort of auditable record that, yes, we said that this could be deployed. The approval process might be web-based, it might be tied to a deployment system. This is the sort of things that makes auditors very happy when you start talking about HIPAA and SAS 70 and all those other acronym soups of certification. Basically what they want is auditable procedures. And people are lousy at following procedures, so if you can make the computers follow the procedures instead, that's great. Okay? All right. Any questions on the Yellow Brick Road before we go on? Yeah.
I just have one, but you may go over this. Some kinds of devices, I'm thinking in particular of Junos, you can basically replace the running config with a new running config, and it will just adapt to it.
Yep.
And some, like Cisco iOS, it's difficult to say, I want to replace whatever you're doing now with this new.
Yep.
Yes.
So to phrase that differently, some devices are automation friendly and some aren't. We'll talk. We will talk about that later. Oh, I'll say it. I've been beating up on Cisco for decades about one thing for another. Why should I stop now? I don't think I'm on any dartboards there at the moment, but I was in the firewalls days. Anyway, yeah, that is something we'll talk about a little bit later. But you're absolutely right. Some devices just suck from an automation standpoint. And classic iOS is the 800-pound gorilla example of that. But we'll talk about some ways that you can mitigate that a little bit. Any other questions before we move on? Okay. So, how do you go about automating the configuration of your network? You've decided that this is a good idea. You've convinced your boss to give you some time to do it. What do? All right. First thing is, you got to know your network. You got to know what it is that you're managing, what devices, what interfaces, what addresses, what domains and subdomains, services. Basically, you need an inventory or a description of your network, right, down to the detailed level. You need all of the information. You need to gather all of the information that you're going to use to generate these consistent configs. Once you know what you're configuring and how it should be configured, Then you start generating the configs for those devices and services. Now, I've glossed over, this is weeks worth of work in a typical network, okay? But, first you figure out what it is you're going to automate, and then you figure out how to do it. And then you figure out how to get those devices, how to get those configs onto the devices in question. This is, we'll talk a little bit more about this later, but it addresses the question from earlier about how some devices are friendlier to this than others. You also need to think about methods for verifying that your changes were successful, that you're running what you think you are. Then, once you've got that in place, you start thinking about change management. How do I do change management and control and so forth? Okay? So those are the 4 basic steps to follow. All right. Now, I'm going to talk really briefly about NCG, what it is, what it does, why it might be interesting. Then I'm going to go back to automation in general, and at the end of this talk, with whatever time I have left, I will go into more detail about NCG. I didn't want to hijack this general talk into, a sales pitch for my open source product. Well, can you have a sales pitch for a free tool? But anyway, we'll do that at the end if we have time. Okay. But briefly, what NCG is and does. NCG generates config files for various devices and services, whatever devices and services you want to give it templates for, that are complete, consistent, and ready to install. So in other words, NCG doesn't do anything about actually installing those configs or activating them. It just generates them. Okay? But that's a big step forward for most organizations, just to even have them generated in a consistent way. Okay? It's open source, released under GNU Public GPL v3. It's written in Ruby. I wrote it on my Mac under 1.8.5. I've tested it under some of the later 1.8s. I don't know if I've tried running it under 1.9 yet, but I don't think there's anything in it that should be a problem under 1.9. Here's the URLs where you can find out more about it and the documentation for it. Okay? The slides, by the way, should be in the agenda for the meeting now, or send me an email and I'll get you a copy. NCG basically works with 2 sets of inputs. The first is a model that describes your network. What are the devices? What are the interfaces on those devices? What are the parameters on those interfaces? What are the IP addresses assigned to them? So on and so forth. It's a tree-structured description of your network. The second set of inputs to NCG are templates. Templates for router config files, sub-templates for interface stanzas of those router config files, templates for firewall configs, for load balancer configs, for service configs such as DNS or DHCP or whatever. Okay, whatever you've got that's network related that you want to generate configs for. First, you describe the network, and then you generate a set. You create a set of templates to use with that description to generate your actual running config files. So then, NCG works in 2 phases when it runs. Right? It's a command line. It's a command line tool. You run it. The first phase builds a complete model of your network in memory. All right. Right now, this is an 0.9 release. It's all in memory. There's no database, there's no backing store, there's no, it basically rebuilds its image of your network every time from scratch. It takes a few seconds for a network of hundreds or thousands of devices. I've tested generating configs out to tens of thousands of devices, and it's, might take a minute or so, right? So it's feasible, okay? The second phase, once it's built that model of your network in memory, the second phase is to then apply the templates to that model, or apply that model to the templates. I haven't yet decided which is the right way of phrasing it. But basically, you combine the in-memory representation of your network with the templates and spit out all the config files for all the devices. Okay? Then you need to somehow, outside the scope of NCG, get the config files onto the devices, using Rancid or SCP or whatever. And we'll talk a little bit about some of the ways of doing that. But, again, NCG focuses on generation of the config files. NCG is also designed with 2 different sets of users in mind. I tend to think of them as the architects and the engineers. Okay? The architects are basically the ones that create the model of the network. They say, you know, this is the sort of information we want to keep track of. This is how we assign IP addresses in our network. This is how we assign host names and subdomains and so on and so forth. They're the ones that sort of write the rules and create the templates that then apply those rules. All right? Then the second set of people is the ones that are going to make, you know, that are going to make the day-to-day changes. Add one more device of an existing type. Add one more interface to an existing device. Tweak this template here. Okay. The second role tends to do things that's more additive rather than, you know, creating stuff out of whole cloth as the architects do. Okay. So the tool is designed to make so that, for instance, the list of routers in a network, for example, can be structured as a simple tab-separated table. Right? The architect says what the columns of the table are and sets up the templates to use those columns in various ways. The engineer who comes along later, who needs to add a new router, can just add one more line to that tab-separated file, and the right things will happen. Okay? That's the idea. All right? So, a little more detail. When you run NC, sorry, was there a question out there? Like I said, I can't really see for the lights. All right. So, a little more detail. When you run NCG, it builds this in-memory data model, interfaces, addresses, VLANs, IP addresses, everything. Combines that with the templates, generates the ready-to-install configs. So where do the templates come from? Okay. Basically, today, you start with a working config for your network, for some device on your network. So a working router config, for example. And you might have this in production, you might have done it in a lab, whatever, but you start with an existing running config. Think about the data. Think about what needs to be abstracted out of that config file. So, for instance, the device name, the list of interfaces on the devices, the device's SNMP community string, the IP address of the syslog server. It's pretty obvious as you read through these. You know, what I usually do is print the config file and sit there with a highlighter and go through and say, okay, that, you know, all of that needs to be abstracted out into the tree and turned into variables, right? And then you also end up doing, like, creating loops of things for things like interfaces, right? So you take the interface stanza for a Cisco router, for example, put that into a sub-template for a particular type of interface, you know, for a Wi-Fi interface or for an interface to your enterprise network or whatever. Then you have a loop in the main template that says, okay, for all the interfaces on this device sorted by interface name, read in the right subtemplate for each of those and emit it to the output. Okay? Works. It's kind of tough to explain, or I'm not explaining it very well, but it works pretty well. It's very useful. And one of the things, by the way, when you do this, is you discover lots of inconsistencies and errors in your existing network. It makes you think about your existing configs to a much greater level of detail. And you find yourself asking, well, why is that there? Or, wait a minute, shouldn't these two interfaces be the same? Why do we have two different types? Why do we have two slightly different definitions of interfaces? Why have we got this command on one of them but not on the other? So, you know, you end up cleaning up your network, cleaning up your config as you develop the templates. So, my experience running this in things like the IETF network at Stockholm that we did last summer is that a moderately complex network of, say, 100 devices can be done in a couple of weeks. Basically, you need a few days to set up the data and the templates for the first type of device. Okay, in our case, for IETF in Stockholm, the first device I chose to automate was the switches, because there were more access points, but the access points were simpler. So the switches were where I got the most bang for the buck by automating the config. Okay, so it takes a few days to extract all of the data, figure out what switches should exist, how IP addresses are supposed to be assigned, You discover things like, over here we say that this network is a /24, and over here we say it's a /22, and then you got to call Jim and say, hey Jim, is that network supposed to be a /24 or a /22? Right? And you get all those inconsistencies worked out. It takes a few days for that first type of device or service. Then, once you've got that one done, you start on the second type of device or service. So in the case of the IETF network, for instance, the access points. That takes a day, maybe a half a day, right? Because you've already got most of the data, you've already got most of the description of your network worked out. And all you're doing now is saying, okay, now what other stuff do I need to deal with this second type of device? What did I forget about in dealing with the first one? And then, the third type of device or service takes a couple of hours. And, by that point, by the time you do 2 or 3 of them, you've pretty much got the model of your network figured out, and it's just a mechanical exercise of converting the config files to templates. And again, not just device config files, but also things like DHCP data files, DNS data files, MRTG, Nagios, whatever your monitoring system is, so on and so forth. All right, so that's NCG in a nutshell about what it does. And again, later in the talk, with whatever time is remaining, I'll come back and talk more about how it does it, and show you the syntax and things like that. Does anybody have any questions real quick about NCG before we move on to other stuff? Yeah. Yeah, I've got stuff. One of my goals, one of my hopes for NCG is that a community will grow up around it that will share recipes and templates and so on and so forth. Hasn't happened yet. I hope it will. I've created a little bit of structure to do that, like a wiki to put those in and so forth. I've got people strongly encouraging me to put the code itself on GitHub so it's easier for people to contribute to the code itself. But yeah, right now the wiki's there. Yeah. Yes. Right. So here's my understanding of netconf, the IETF netconf protocol. I'm not sure, it's not commonly enough available on enough platforms and so forth to be usable yet, really. It shows some interesting promise, right? The vision for it is kind of cool, but it's not there yet. The other one that was out a few years ago, Jim, do you remember the one that Elliot worked on a couple of years ago that was more about just getting configs onto the devices? What? No, it wasn't ZeroConf. I forget what the name of the protocol was, but basically it was a standardized way of talking to the device and saying, here's your config. I don't know what the config is. It's just a blob of text or binary data, but here it is. Okay, that was useful. I think that was called netmod or something like that. But, again, that one got a little more widely implemented, but, none of these have reached what I would consider to be critical mass, unfortunately. Another question there was over here. I saw. Yeah.
You talked about the benefits of automating, and then you mentioned that the way that you generate the NCG file is to print out a configuration on paper and take a yellow highlighter.
As a starting point. As a start, well.
Any consideration taking that?
Yeah, and automating that process.
Saying,
yeah.
Generate an NGC file.
Yeah. Oh yeah, I've thought about it. That would be something maybe I would sell. No, seriously, that is where I would like to go in the future. And basically be presented with a config file on screen and in an automatic or a semi-automatic way, work out the templates from that. Yeah, but I haven't done anything to implement along those lines yet. Yeah.
One thing that I think of that has a lot of tweaking would be your IGB columns.
Mm-hmm.
Do you look at it as a link, or it's not necessarily specific to an individual device or in this case a version 5, but it has a full scope.
I haven't tackled that in any depth yet. I do know that there are organizations who generate using other tools, not using NCG, but using other tools, pieces of their config files. They generate the BGP conf, they generate the ACLs, they generate whatever. So you could apply those same principles within this tool as part of generating the larger thing. I think it comes back to data structures. I mean, you got to think about what your model is first and then how to generate from that. And here, I guess I'm exposing the fact that, I started life as a programmer, not as a system or a network administrator, lo these many decades ago. So, other questions? Someone at the back. Does it support NetScreen CLI or Checkpoint? NCG basically just treats configs as text files. So if it is a config that can be expressed as a text file, how you get it on and off the device is independent of NCG at this point. So it'll support anything you want as long as it has a config that looks like a text file. From my point of view, an XML file is a text file from NCG's point of view. You can generate XML just as well as you can generate anything else. I've used it I personally have used it to generate Cisco configs, Juniper configs, which are sort of XML-ish, DHCP data sets, DNS data files, Nagios config files, which spread across multiple files for a single config, MRTG config files. So, basically, it's a program. You can have it put out whatever output in whatever form you want. So, where it would not be, we talked about some devices being automation unfriendly. Another example of an automation unfriendly device would be a device that can only be configured via a web GUI. What am I supposed to do with that? So consumer grade routers and DSL modems and things like that. So, yeah. I haven't tried to do any API integration with anything else yet. No. All right. Any other quick questions on NCG before we go talk some other stuff, and then we'll come back to NCG. All right. Okay. Rancid. I halfway wonder if I should just skip Rancid because everybody here knows what it is and is using it, right? So, but I'll go through it really quickly. Rancid is basically a tool for going out and started out as a tool for going out and getting the configs off your Ciscos and sending you diffs of those configs compared to what they were the last time the tool run. It has been extended to 37 or I don't know how many different types of other network devices, products, vendors, manufacturers, and so forth. But basically all your major vendors at this point, you can use Rancid to get configs off of those devices. There was a great talk, actually, about this at a NANOG many years ago, but it's still about the best introduction I've found to Rancid. Here's where it's available from. It's also available as an installable package on a lot of different operating system distributions, so that's a quick and easy way to get started. Some how-tos, again, how to get started with it really quickly. So Rancid has a series of config files. The main config file basically says where are all the other files, okay? And whether you're using CVS or Subversion for your source code control, for your version control system, and a list of the group names for different sets of devices. So for instance, you might group your devices functionally. You might have one group for routers and another for switches and another for load balancers, or you might group them organizationally. You might have, one group for site A and one group for site B, or one group for department X and one group for department Y, or whatever. You can, the groups can be whatever you want them to be. So for each group, there is a router.db file. And that is the list of devices for that particular group, that are made up, that are part of that particular group by your definition, and what type of device they are, so that Rancid knows how to talk to them. Are they Ciscos? Are they Junipers? Are they not Flowpoints? Sorry. Are they F5s? Are they Nortels? What are they? And then also, there is a file that's called the .clognrc file, which has all of the passwords and other credentials for all of the devices that Rancid would need in order to get in and get those configs. That clognrc file is obviously extremely security sensitive because it's got the keys to the kingdom. Okay, so you got to guard it very carefully. Now, just as an aside, the router.db files and the clognrc files are both files full of device-specific information that whenever you add a new device, you need to change these files. Hey, that sounds like a great candidate to generate with NCG. Yeah, okay, you can apply it to these things as well. I think I did that for the IETF network. So there are basically two sets of programs with different names for different devices and so on and so forth. The programs that are whatever rancid are to get the configs off the devices. That's the function of those programs. And the programs that are whatever login, so C login for a Cisco or J login for a Juniper or whatever, those are ones that are used to access the devices and run commands. They're basically the first set of programs are wrappers around the second set. Right? The login programs give you access to the different devices, and the rancid programs actually get the configs, diff them against what the previous configs were, so on and so forth, using the access provided by the login program. So that's the basic structure of rancid. Now, as I said, I've listed 5 platforms here. I think there's something like 30 or 40 platforms that it currently supports. It is a god-awful huge set of Perl scripts. But one of the things that you can do with rancid that a lot of people don't appreciate, or they don't know that this feature is there, is you can use them to execute commands on the devices. You can give a command to a device through rancid. So the login program, the C login or J login or whatever, handles the details of logging into the device, becoming the super user, and issuing whatever command you give it. And it can do things like issue multiple commands separated by semicolons, just as if somebody had sat there and hit return at the end of each command and so forth. So it has a very limited capability for dealing with interactive responses, right? If you can predict the response that's needed, then you can just send the command. So this reminds me a lot of working out AT-DT strings for modems, right? For those of us that go back that far to have to have dealt with that. But if you can second guess well enough what it's going to do and what the timing is and so forth, you can make this work. Okay? A better idea is to create an expect script that is basically a program, simplified program for dealing with the device. If you see this prompt, give it this answer. If it asks for this verification, say yes. If it asks for that, say no. Whatever. You can do some simple branching and things in there, and just gives you more capability. And there are a handful of sample files of these expect scripts included with the rancid distribution and the rancid add-on package. So, like I said, it would be natural to integrate something like NCG with rancid, using NCG to generate the device configs and the rancid configs that have per device info in them, and then using rancid to go and put those configs on the devices in question. Okay, so here's an example from my lab. If you download these slides, you can read this in more detail. But basically, this is using the C login program, the Cisco login program that's part of rancid, to copy a generated config file for a Cisco onto the Cisco, and then, well, actually, that's all it does is copy it on there. It makes it the startup config on that Cisco. So the next time that Cisco is rebooted, that's the config it's going to use. Okay. This is an example of, what is this an example of? This is an example of another way of copying the config onto the Cisco using HTTP to pull it from the Cisco side. This is an example using config replace on Cisco. How many people have never heard of config replace on Cisco? Lucky you. All right, let's talk a little bit about config replace. To put it bluntly, from an automation standpoint, from a I want to make this change, this fairly bounded change, and just have it work. From an automation standpoint, iOS sucks. Okay, it's horrible. It's just not what it was. It was not something that was in mind when it was written. Okay. So the biggest problem is that whatever iOS commands you send, and whatever config commands you send within iOS, they tend to have a lot of side effects. So if you say delete something, you delete an interface, for example, mentions of that interface disappear from other parts of a file. Okay, so it just makes it really hard to predict, hey, what, I'm going to issue this line of text as a command. What effect is that going to have on the config that's running on the device? Okay, so one of the things that Cisco offered in a not too distant past version of iOS, and it's been backported into a lot of versions now, is this thing called config replace. Config replace is supposed to take a new complete config file and, without rebooting the device, figure out what needs to be done to go from the current config to the new config and do it. Now, in my experience and talking to a lot of other people that have tried to use this thing, if the config change is anything complex, it tends to fail. Because, and it's funny because it shows you what I would think of as debugging output while it's running. And it looks to me that what it's doing is iteratively trying to figure out what changes need to be made to go from A to B, and it goes through about 5 passes and then gives up. Okay. It is safer, however, more disruptive, to simply put the new config file on the device as the startup config and then reboot the damn thing. That is the reliable way to change the config on a traditional iOS system. Now, I'm not talking the new, MX1000 or whatever the new, 3-rack monster is that runs next gen and such. I don't know anybody who has one of those. I mean, I'll probably meet some people this week that have those. Okay, I'm talking your classic iOS, Catalyst 7000, whatever, classic iOS stuff here. There's still an awful lot of those classic iOS boxes in the world, and there will be for a long time. So I think this is still a valid problem, even if Cisco says, oh, we fixed that in, this $1 million box that isn't really, something everybody's going to replace their branch office routers with. Anyway, by the way, when you do a reload, when you do this method of replace and reload, it's really helpful to have something watching the serial console or whatever console your device has, so that you can catch any complaints during the boot process about mistakes that might have made it into the startup config. They would be representative of data or template errors in your generation, but you need to know about them in order to fix them. All right, so how do you reload a Cisco via Rancid? The brute force way, assuming that you definitely don't want to save your current config because you've just written a new startup config to the device and that's what you want it to run. You want it to reboot to run that. So no, don't save my current config over top of that. The command above assumes that the Cisco will prompt you to save the current config. You want to say no. Sometimes it will, sometimes it won't. It's safer to use the Cisco reload expect script that comes with Rancid because it deals with these. If it asks, do I tell it this? And if it doesn't ask, I just go on and do things and so on. So it's an example of using expect scripts, like I said, with Rancid. By the way, another thing you can do with this tool and with the Cisco reload thing in general is you can specify a time at which the reboot should happen. It doesn't have to happen immediately. So sometimes that's useful. Or you can specify a reason for it to put in the syslog message. Sometimes that's useful too. All right. Any questions on Rancid before we move on to ZipTie? Yeah.
Your config replace, I'm not familiar with that particular command. Is that similar to copy, start, run? Do the same thing? Make a start configuration, but then run config?
How does this override? It's supposed to do the diff and say, oh, there's no OSDF config on my save config, so I'm going to run the OSDF config. Where if you just copy and start running, it will just, if you have something there, it'll leave it dead.
Yeah, I'm.
How would startup run as if you type everything and start up?
Yeah. I would think that copy startup run is going to do all sorts of weird things because the state of the config at any given point during that sequence, Lord knows what it is.
Without explicit nodes,
Yeah.
every possible iteration.
Yeah. So I don't think that's workable. It hasn't been in the times I've tried it.
It'll work in a very simplistic environment.
Yeah. but not many real-world environments. It doesn't even work in my little lab with Cisco 3600s. So, yeah.
A thing I'd like to point out about Rancid, if you don't have automatic config generation, it's really nice to tie it in either looking at your syslogs or looking at your TACX logs, so when someone does make a config change, it goes out immediately
Yeah.
and grabs it.
Instead of, cron job every hour or whatever. Yeah.
Having it proactively go out to the device.
Yeah. Yeah, that's a good idea. By the way, for monitoring syslogs and things like that, if you haven't played with Splunk yet, what are you waiting for? Please, that tool is almost revolutionary for dealing with logs. Okay, other questions before we move on? Okay. Zip tie, also known as Alter Point Network Authority Inventory. I like zip tie name better. But anyway. ZipTie is a web-based GUI environment for managing networks. It goes out and discovers devices on your network, backs up the config, maps your network, discovers neighbors, lets you find devices by host name or IP address or MAC address, can generate configs for some types of devices, or sorry, not generate configs, but can put configs on them. Can do reports and graphs and so on and so forth. It is web-based user interface, AJAX or something like it. Includes a framework for you to add your own plug-in tools. So, for instance, you could integrate. I haven't tried this yet, but it's on my list of things to experiment with when I've got a client who wants to pay for it. Is to integrate NCG with ZipTie so that NCG would generate the configs and then ZipTie would put them on the devices. You can create schedules for jobs. So, when do I do discoveries? When do I do backups? So on and so forth. There's some screenshots included in the presentation here. So, like I said, you can do backups and restores. You can push a config. One of the tools in there that I really like is this side-by-side diff for config files. It's actually a fairly useful tool for comparing two versions of a config file, or the config file for two different routers at two different sites or something like that, side by side, and showing you the differences between them. It's a supported package available for Ubuntu and Windows, unsupported available for other variants and Mac OS X. It's also available as a VMware virtual appliance, so if you just want to run a VM image on your machine. Requires JDK, requires Perl, excuse me. Sorry. Requires a whole bunch of Perl CPAN modules, which in turn have an undeclared requirement that you have make installed on your system. I beat my head against this for hours getting this thing installed before I discovered the problem was that there was no make on the system, and CPAN needs make. And anyway. I talk a little bit here about how to install a generated config. So basically you generate your config, write it to this directory, and then use SCP or FTP or something like that, or you tell ZipTie to use NCG or FTP to put it on, to use SCP or FTP, I'm getting tangled up in my acronyms, to push it out to the device. In my experience, you need to check carefully whether or not it succeeded, because I've found instances where it reports success and yet the config never got there. So you need to trust but verify. Licensing status on NAI seems a little bit muddled. It was developed largely by AlterPoint, and a lot of the plugins and things like that are community provided and supported. It was originally released as open source under the Mozilla license. However, in 2008, AlterPoint rebranded it as NAI and released it under a new license of their own devising, which they call an open core model. And among other things in the license, it says the product is downloadable and can be used freely for internal business purposes. All right, what does that mean? What if my business is configuring other people's networks? So, I don't know. Have a look at the license, decide, with your own attorneys whether or not it's something you want to get into or not. Other tools, vendor-specific device configuration tools. Every vendor seems to, have a checkbox item somewhere that says, yes, we have a device configuration tool. it only works on our devices because you're only going to ever have our devices on your network, right? Yeah, no. But they all have them. You may be able to use them as part of your total solution to deal with that particular brand of devices. But usually I've found that they just aren't that much help. They're a sales checkbox item, and they're not that useful in the real world, in my experience. All right, let's talk. We got about a half hour left, so let's talk more about using NCG to config, to generate configs. So, for example, SNMP status monitoring, Nagios, or whatever monitoring tool you want to use. I just happen to use Nagios because it's the one I'm most familiar with. You use NCG to generate your config files for Nagios by walking the list of devices that NCG has built up in memory in phase 1 of the NCG run, and generating a series of device-level monitoring directives. You know, what do I want to monitor on this type of device? CPU load, fan, temperature, memory usage, whatever. What interfaces exist on this device? What do I want to monitor on each of those interfaces, right? So there's an example included with NCG in one of the examples of doing this for a web hosting service. Okay. Now, what about trend monitoring? You know, pretty pictures and graphs and things like that of error rates and bandwidth and throughput and everything else. Again, you can use NCG to generate the config files for a tool like MRTG, and there's lots of other tools out there besides MRTG. MRTG includes a package called CFG Maker to generate its config files because its config files are rather complex. But basically what I found that most useful for is use CFG Maker to generate the first config file for your device, and then use NCG to regenerate it. You basically convert that to an NCG template and then use NCG to regenerate it. You might ask, well, why not just rerun CFG Maker every time? And the first thing to wonder is, okay, when do I need to rerun CFG Maker? When do I need a new MRTG config? The other problem is that CFG Maker and the associated tool, which makes the HTML index files, they go out and query the device in question in order to figure out what to put in the config file, which is great if the device is up and all of its interfaces are up in the way you want them right this second. But if you happen to rerun the device or if you happen to rerun CFG Maker while the device is unreachable, or while some of the interfaces on the device are administratively down or something like that, you're going to get changes to your monitoring config that you don't want, that reflect the state of the thing at that moment, not in the larger scheme of things. Okay. What about DNS? Here's an example of this is an example of a NCG input file that basically says, let's generate all my DNS data files, my forward lookups, my reverse lookups, and my IPv6 lookups. Boom, include this, you're done. Here's what the template looks like for the domain file itself, the zone file itself. This is, let's see if I got, does it give me a pointer? I guess not. You get, it's Ruby, embedded Ruby code, which we'll talk about in a little bit when we talk more about NCG. But basically, you're iterating over the list of devices in your model and spitting out the A or the AAA record, sorry, the Quad A records for all of them. Sorry, I've been watching too much History Channel lately, and I think of AAA instead of Quad A. Similarly, you have a template for your inatter.arpa file and for your IP6.arpa file for your reverse lookups for both IPv4 and IPv6. DHCP, again, use NCG to generate your DHCP config files with your statics and your dynamics and so forth. It's just like walking the tree to generate your DNS data files. And in fact, since you're going to generate both your DHCP and your DNS data files at the same time from the same tree, they're going to be consistent. That's a good thing. That's very useful. Okay. Using it to generate access control lists. Again, there's an example in the web hosting example that's included with NCG that shows how to use NCG to generate access control lists within a router config, a switch config. This is an example of a sub-template of a template for a particular type of interface, for a VLAN interface in one of those examples. So, basically it goes through and modifies your access maps and your ACLs and so forth based on the data in the tree. VLANs, there's examples in there of how to deal with that. VPNs, host automation systems. Well, how would you integrate NCG with something like Puppet or CF Engine or something like that? Well, the big question is, who's going to be the king? Are you going to configure NCG from Puppet, or are you going to configure Puppet from NCG? Depending on whether you are a host-centered or a network-centered provider or enterprise or whatever, either one of those might make sense. I don't really care. I've designed NCG to be, it can be the top dog, or it can answer to somebody else. All right, tips, tricks, and random observations. How many people knew that you could copy configs on and off of a Cisco via SCP? How many people didn't know that? That's a better question. Oh, everybody knew that, almost. Okay. Well, you can. It's a pain in the butt to figure out how to do it, how to set it up, but here's all the commands you need in one place. Okay, so you can set your Ciscos up so that you can just easily SCP the config files on and off. We talked a little bit about config replace already. Again, it lets you replace the running config with a new one without rebooting. Like I said, I would consider it, and I think most people who've tried it would consider it not quite reliable yet. Maybe for small, simple changes, but nothing significant. It does allow you to do rollbacks and have an optional timeout parameter, so that if, for instance, your change inadvertently cuts you off from the device, well, it will theoretically roll back to the previous config if you haven't confirmed the changes within whatever period of time you've told it, 60 seconds or whatever. It does require you, in order for this to work, you do have to have a config archive to be set up off device. And it has to be able to reach that config archive to get the old config to put back. Wait a minute, I see a problem here. Yeah, okay. Sorry, somebody over here and then over there. Yes, that's true. Now, somebody over here.
That's exactly what I said. That's what reloading is.
Yeah, okay. Yeah. Automation-friendly devices and configs. What do I think of as an automation-friendly device or service? It's got to be something that can be configured via a CLI, something text-based. It's a pain in the butt to deal with things that are purely GUI-based. Sorry? Oh, I guess that's out in the hall. And it needs to be a config that you can replace in whole, rather than having to edit in place. The editing in place is trickier. So, for example, for SNMP monitoring, MRTG is a good automation-friendly service because the config file is text. You can regenerate and reinstall the entire config file, and it just works. Cacti, on the other hand, not so good because the config is via a GUI, and there is an API, but the API is actually not that great for automation because the last time I played with it anyway, the API was of the form replace the config for template number 37 with this. Well, how do you find out what template number 37 is? Outside the scope of the API. Okay, that doesn't work. So, maybe they've fixed that. Maybe they've extended the API by now. But when I played with it a year or two ago, it wasn't useful yet. This is kind of a basic operating principle that I try to follow, which is once you get your system to where you're running in this sort of an automated environment, the database is always right, by definition. If the database is not right, fix the database, right? keep it, you don't want to be tracking in your head or any other way differences between what the database thinks ought to be and what's in production. Sometimes, yes, you have to go fix things in an emergency by hand. But as quickly as possible thereafter, you should fix the database so that your fix is made permanent. Okay? So, for instance, when I was the network architect at COVAD, okay, COVAD's DSL service offerings went up to 1.5 megabits. Now, I happened to live 2 blocks, maybe 3, from the Mountain View 21 CO. Right? I live right down Dana Street in downtown Mountain View, if you folks know where that is. And, you know, I could crank the speed on my lines at home all the way up to 6 or 7 megabits. And this was, remember, this was in 1999 or so, when that really was the fastest DSL could go. But every night at 2 a.m., boom, my lines would be bounced back to 1.5 megabits because that was the fastest supported speed, and that was what the database said that the line should be configured as, and you know, whatever changes I had snuck into the production network to make by hand earlier in the day got overwritten, and that was the way COVAD ran its network, and I'd argue that that was a good thing. That meant that that network was consistent. That network was easy to troubleshoot, easy to manage. Okay? So kind of a corollary to that is, don't fix what you don't understand, right? So if the automated system, if you're running an audit of your via your automated system, and you find something out of place, you find something that's not the way it should be, what you probably want to do at that point is flag that and alert a human to decide what to do about it. You probably don't want to just automatically replace it unless you really have gone whole hog on the automation thing like COVAD did and said, you know, look, the automated system is how we're going to do things, and it's the last word. And yes, we are just going to overwrite whatever got put there by hand. There's valid reasons for doing that, but that's an extreme stance, I think. Another corollary, have one source of truth about your network, right? Have one database that has all your IP address assignments in it. Right? Try and centralize things. For any given fact about your network, the name of a device or the IP address or whatever, there should be one place where that fact is recorded, and every other place that that fact is used gets derived from that one place. You should not have to, if you're going to change the IP address of a device, you should not have to go change it here and there. Whenever you start saying and, do something else. Oh, no, something's wrong here. Okay. Here's a little bit about human psychology and so forth as it relates to these sorts of automated networks. Everybody wants to be a hero. That's fine. That's perfectly natural. I do search and rescue as a volunteer, so you know this is fine. We count on this. In most organizations, management rewards heroism. Something broke, somebody saved the day by fixing it. That somebody gets a reward for fixing it. Okay? It's hard to reward people for something that didn't happen. It's hard to reward people for a good design that prevented that incident from happening in the first place. But it's important to figure out ways to do that because you really want to encourage, you don't want to reward fixing things, you want to encourage not having things break in the first place. Okay? Now, people that get a lot of their rewards at work through being Mr. Fix-It or Miss Fix-It or whatever, they are unconsciously going to push back against automation systems because those automation systems are going to reduce the opportunities for them to get patted on the head for having saved the day again. You have to figure out a way to deal with that organizationally. You just do. Okay? How do you go about introducing automation to existing networks? Because we're all dealing with existing networks, generally. Okay? So how do you go about introducing automation to an existing network? My advice is start with just one of something. One type of service, one type of device, one location, one data center, whatever. Preferably something that is new and not yet essential. Okay? So like say a new VPN deployment or a voice over IP deployment or some new SNMP monitoring system. SNMP monitoring systems are a great thing to use as automation test cases because they generally are read-only to the network. They don't change things on the network. They just report on what's there. And so if they're not working, the reports on the new monitoring system are wrong, but we're not depending on it yet anyway, right? So, you know, they're a nice test case for this sort of stuff. Or something like a new site or a new rack or whatever. Starting that way gives you a chance to get some experience with your tools that you're trying to introduce, your automation tools and so forth. And it gives you something where you can show your peers and your management, see how much easier this is with automation, see how much more reliable this is and how much better this is and so forth. You know, it helps you make the case to get everybody else on board. Okay, okay, real briefly, I'm going to talk about special circumstances. Automation is a great thing for things like QA labs, test beds, and development environments because it lets you spin them up quickly and change them quickly, and when you've got them the way you want them, reflect them over into production. Okay? If you have an automated tool generating configs for an 8-port switch in the lab, and you get that switch the way you want it, it's pretty easy to then use those same templates to generate the configs for the 192-port switch in production. Okay, so, you know, very, very useful. Which, you know, this can give you a whole different way to do development and QA and so forth for your network services, you know, in a way that you may not have been possible before. IPv6. Had to throw in something mentioning IPv6. Enabling IPv6 is going to require lots of little changes all over the place, right? And you've got to enable IPv6 on the device, you've got to assign addresses, or else you've got to turn on RA or whatever. If you're generating all of your configs, it's a lot easier to make all these little changes that you're going to need to make in order to enable IPv6. Okay? Cloud computing. If you're a cloud provider, you've got to automate the configuration of your network. If you are a cloud provider, you don't have any choice, and chances are you've already done something. If you want to be a cloud provider, you've got to be thinking about this sort of stuff. And that's regardless of whether you're a cloud provider to external or internal customers. Just, you know, you can't do it without automation. Things like COBIT, ITIL, you know, the management acronym buzzwords and things, those things are all about best practices and process repeatability. And automation is how you achieve process repeatability. Okay, so it gives you a way to reliably, repeatably configure your network according to whatever your central plan is. All right, strategies for promoting automation. If you're trying to convince management, you want to emphasize increased reliability, easier and therefore cheaper troubleshooting, both in terms of a quicker return to service when there is a problem and less staff time spent troubleshooting as opposed to whatever else they ought to be doing, easier and cheaper maintenance, and easier and cheaper upgrades and growth and scalability. Those are the arguments that work with management in favor of automation. Yeah?
A couple I ran into is finding admins who are comfortable writing Ruby or finding Ruby and comfortable doing updates for products. So you have to convince management that needs to exist. And then when we hire a CCNP who knows iOS, why do I need to have someone in Ruby? How do you maybe respond to that one?
Like I said, I think you have to show them the benefits and say, you know, if we have one person who can do both, great. If we have to hire, you know, 2 half people to do it, one person to do the Ruby side and one person to do the networking side, it's worth it. You know, if you want a more reliable, more scalable, better manageable network, this is the path. If you don't want to invest in it, you're going to be stuck with what you've already got. I mean, it's harsh words to them, but that's basically, they don't get it for nothing. You know, and like as you said, part of it is you need to either apply some networking skill to your programmers or some programming skill to your networking, or both. You know, but it can go either way. Other questions? Yeah.
So we have a situation like this. This Earl person helps do this, another guy puts some Python scripts on this Python script out and builds a lot of byte routers.
Yeah.
And it tends to run on 30 routers and fail on 20 for reason. So what we have basically is the engineers are allowed to go change the devices correctly, and then we have half of the factories that parse them big
Yeah.
and try to apply policy.
Yeah.
So I would think that it might be easier in that environment to do something. I could say, for instance, I can take this tool and just handle the SNMP part of the system.
Sure.
Demonstrate that it works.
Mm-hmm.
But that means I don't want to replace the entire config.
Sure. Again, NCG generates text files. If the text file happens to be a complete config, great. You can use some tool to install it. It doesn't install anything. If it happens that what it generates for you is a partial config file, great. You could have it generate the complete text file, for example, the complete config file, for example, by saying, here's what comes before the generated part, here's what comes after the generated part. Generate everything in between, and then just glue these two pieces onto either end. That's workable. Other questions? Okay. Arguments to convince your coworkers, arguments to convince staff. I think here what you want to do is emphasize that automation makes the network easier to work on because it's more consistent. Okay? It is more reliable because it is more consistent. You spend less time firefighting and more time extending, either in scope or in service, the network. Right? And you end up dealing with fewer middle-of-the-night problems. Right? Again, it makes the network more predictable and easier to extend. Those are the arguments I would use with staff. Now, as I said when I talked about everybody wants to be a hero, there are certain personalities that are not going to be convinced by this. They are not going to see these things as features because it means they don't get to be the hero anymore. And whether they realize explicitly that that's why they don't like this idea, or they're just resistant to it without really contemplating why, it's a problem. And you as an organization have to decide what kind of network you run. And, part of that might be deciding that, these certain people have been great for us so far, but they just don't have the right attitudes and the right skill sets and so forth for the way we're going to run things in the future. That's tough. I mean, I've been there as a manager, and it's a tough place to be. But if you want to make your network more reliable and more scalable and all these other good things, it's something you have to contemplate. All right, resources. I blog about automation stuff occasionally on my blog. I maintain a wiki and a network automation mailing list on this middle site, the Automata community. The Cisco iOS Hints and Tips blog, which is put out from Eastern Europe, I love that thing. If you've got Cisco's in your network, or even if you don't, you ought to subscribe to that blog. I find it very, very useful. Get all sorts of little tips there. Tools, here's the URLs for all the tools that I mentioned earlier. And that's it for the prepared, well, I've got more prepared. That's it before I divert into details of NCG in 8 minutes. So I have 38 slides left to cover in 8 minutes, which isn't going to happen, obviously. But anybody who wants to stick around and hear a little more about NCG, please do. But if you have questions, ask them now.
Quick question. So it looks like the sort of strategy of build a device now and generate configs for everything on every single run.
Yes, that's the way it works currently. Yes. So the question was asked me to confirm that right now when you run NCG, it regenerates all of the configs for all of the devices and services every time you run NCG. And I said, yes, that is the way it works right now. So then there's a follow-up.
Is there a strategy for figuring out what you need to push out to devices so you may not want to hit all 1,000 devices in the network?
Right. So then the follow-up question is, okay, so then how do you decide what you actually need to push to which devices and so forth? I haven't tackled that yet. Definitely in order to scale this thing, something like that would be necessary. Right now it would be fairly, basically right now it would be, did anything change in this config other than comments? For example, that's one of the things I often apply to my Cisco diffs, because one of the things that my templates do, and this is, just a choice in my particular templates, is they put comments in to indicate when that config was generated by NCG. So it's, and so that comment is obviously going to change every time. But, I can diff against the last pushed one and say ignore the comments and decide whether I need to push this new one. Things like that. In the long run, I could see this thing getting to be database backed and, having some sort of smart stuff in there that's, dependency tracking like rake or make or whatever, and figuring out what new configs need to be generated based on what data has changed. But this is not even a 1.0 release yet.
A fairly pretty straightforward approach to that would probably be if the target location for your NCG generated configs is a working copy of some version control system like Subversion or something like that, then after you run NCG, you can tell the version control system to tell you which files to
Yeah.
and use that to figure out what needs to be changed.
Yeah, which content file, the content of which files have changed, because all of the files are going to have updated M times.
Right.
But yeah.
Can you talk a bit about, like I said, the culture I think we had a diagram of lifetime experience from
Mhm.
devices that was unreliable. And Cisco used to have part of System Works and other tools that would execute a single command on 50 routers or whatever.
Yeah.
We found that was also, you could never trust that somebody would happen to watch it.
Yeah.
Can you just talk about that in general?
Well, okay, so the question was, how do you deal with unreliable tools? And sometimes they're written in-house, sometimes they're provided by vendors. What do you do with unreliable tools? One of the reasons that I have written NCG and am promoting it and so forth is I would like there to be a tool that all good networks use, that the community contributes to the support and maintenance of, and that becomes, something you can hire people that you expect to understand it, and what you learn about it you can take with you to your next job and so forth, rather than the current situation, which is you start from scratch every time. Every new network, you start from scratch developing automation tools specific to that network. Every time you go to a new company, you're learning a whole new set of tools and things like that. I've watched over the last few years what has happened in the system administration world around tools like CF Engine and Chef and Puppet, and how communities are starting to grow up around those tools, and templates and things like that, and recipes and cookbooks and so forth are starting to develop around those tools. And that's what I'm trying to facilitate. We're a long way from there. So, other questions? Yeah.
Can you say a few more words about why the Cisco iOS CLI is so bad in relation? And what we can do is to make a better one.
Can I say a few more words about why Cisco iOS is so bad from an automation standpoint, why the CLI in particular is so bad from an automation standpoint, and what could be done to improve it? The basic problem, from my point of view, again, just with respect to automation target, is that iOS, the Cisco config files aren't really config files. They're batch files. They are files full of interactive commands, just like old DOS batch files. And a lot of those commands, when you issue them, have side effects. And the order in which they are issued matters a lot. And the state of the device, the state of the device when you start issuing those commands matters a lot, which is why, for example, you cannot simply do, what somebody was asking over here, which is, why can't I just, execute the current config or the new config and apply it to the current config? It's like the state's all wrong there. The new config assumes you're running against a machine that has just been booted, that is in the default configuration, right? So basically what I think would need to be done, and I haven't looked at the like iOS 15 and things like that, or the next gen and so forth from Cisco, so maybe they have done this, I don't know. But what would need to be done is take a different approach to configuration. Now, if you want to talk about a vendor that I think has done it right, go look at Juniper. Right? The way Juniper handles, I'm sorry, I know that, that people are going to say, oh, Cisco versus Juniper, whatever. Look, in my opinion, as somebody who's dealt with this for years, the way Juniper handles config files is just light years ahead of the way Cisco deals with it. We can argue about all the other features of the routers and so forth, but if you want to talk about config management, Juniper got it right, Cisco didn't. So. And which is also, by the way, why it really annoys me that so many new vendors are saying, oh, well, we emulate the CLI, iOS CLI. That's what everybody wants, right? It's like, no. Okay, anyway. Other questions? Yeah, back.
Earlier reference
So I mentioned something about when we were talking about log analysis and syslog and things. I threw out on a side that said, you know, if you aren't using Splunk, what are you waiting for? It's splunk.com. Okay, the simplest way. They hate it when I describe it this way, but the simplest way to explain Splunk is it's Google for your log data. It is this incredibly powerful interactive tool for exploring your log data. Now, you can also set it up to do things like, you know, watch for this and alert me if that happens and show me histograms. And it's like, you know, when AltaVista and Google first came out, you can't really explain what they do to somebody who's never played with it. So it's free to download and use for up to 500 megabytes a day of data, which is an actual, you know, you can run production stuff on 500 megabytes a day of data into this thing. So go get it. Set it up on one of your systems, feed copies of your logs to it, play with it. It'll take you about an hour to become convinced that, you know, you can't live without this thing, and it'll take you about a day to build up some internal use of it that, you know, you can then go justify getting money for it from your boss. I mean, it's a cool tool. And they're here in San Francisco, and they're having their first user conference in August. So, you know, if you're doing anything with them or thinking about them, go to that conference. Other questions? Okay, well, it's 5:30. Officially, we're done. I'm going to be here all week, so I'm happy to talk about NCG at other times with people. You know, if anybody's really curious what the files look like and the config files and things like that, come grab me. I'll have my laptop with me and I can show them to you. Thank you all very much for coming, and enjoy the rest of the conference.